Greetings, everyone. My name is Dr. Ann Nate. I'm the Director of the Energy Systems Signature Area and the Future Energy Systems Research Program at the University of Alberta. On behalf of the University of Alberta, the University of Texas at Austin, and the Tecnológico de Monterrey, I welcome all of you to the fourth webinar of the North American Energy Dialogue series entitled Industrial Decarbonization and the Role of CCUS, a Canadian Outlook. Our three institutions are leading research-intensive universities in their respective countries, each with strong energy-focused expertise. And we are uniquely positioned to create a platform that enables discussion and analysis on important energy topics through a North American perspective. So today, we're going to be taking a closer look at CCUS technologies and the critical role that they can play in reducing industry sector CO2 emissions. The focus today will be on Canada's current energy landscape, drawing upon perspectives and experiences from experts in the United States and in Mexico. Our four leading experts here today provide perspectives on CCUS and industry decarbonization, and they represent Canada's federal government, a multinational company, and of course, academia. Now, I'm delighted to introduce you to University of Alberta's Dr. Rick Cholaternik, who will lead the show for our discussion today. Dr. Cholaternik is a professor of geotechnical engineering and holds an NSERC Energy Simulation Industrial Research Chair in Reservoir Geomechanics. His primary research in unconventional resource geomechanics and geological storage of CO2 is extensive and impressive, including development of 4 unique geo-innovation environments at the University of Alberta. Now, his influence in the CCUS space extends well beyond North America, and this includes serving on an international peer review team for the Australian governments, chairing the committee that developed a binational standard with the United States for geological storage of CO2, and participating in several working groups which developed international standards for CCS. Now, I know he can talk for hours on today's topic and has a wonderful way of making this complex topic understandable and relevant. Over to you, Rick.
Super. Thanks, Anne. Thanks for the introduction. Yeah, no, I'm quite excited about the conversation today and looking forward to the conversation with the three panelists today. So, let me share the screen, and just to kick things off, yeah, so the topic for today's dialogue is actually an increasingly important one. There has been a lot of work in the world of the power generation side for CCUS, but today's conversation is around industrial decarbonization and its challenges. And I was fortunate to borrow an image of a recently released website that is talking about the Government of Canada's CCUS road mapping exercise. So it's a nice graphic that sort of captures the complexity of the topic. So for today's conversation, I'm going to assume that most of the people on the call understand carbon capture, utilization, and storage. These are just the typical descriptions for this for everybody. Suite of technologies, down from capture in multiple sectors, multiple settings, including directly from the air capture. Once it's captured, it's compressed, transported, and in many cases, the utilization might be for something like CO2 enhanced oil recovery, or in sequestration or pure storage, injection into geological formations underground. And then there is the product side for utilization, where it can create products as low carbon synthetic fuels and concrete. So One of the things that's important about CCUS technologies is that it's a part of an enabling technology as well to enable negative emissions in terms of direct air capture and biomass energy for storing CO2. Now, for these few introductory comments, because I only want to take a few minutes, this is really about a conversation with our three expert panelists. But just to set the stage a little bit, there are, over the last, let's say 2-3 years, there have been, a number of reports that have come out to really take a close, focused look on issues around the challenges in the energy transition largely, but even in a more focused way, the challenges in transforming industry or decarbonization of the industry sectors, which generally is cements, chemicals, and steel. But there have been some great reports, some of them there in the images. Energy Transition Institute, McKinsey, UK has developed its own industrial decarbonization strategy. So there are a number of places. But for today, I thought I would just for the conversation is just speak to the report that the IEA put out in 2019, which was really this focus on transforming industry through CCUS. So they identified kind of four, if you want to call it, four major particular areas that were identified. Was that industrial production as a part of the whole energy transition really does need to be a part of that transformation to meet climate goals, the Paris agreements and so on. But the industry component of that sort of portfolio of industries that need to be decarbonized, the cement, steel, and chemical sides is really important to allow us to meet climate goals. They've identified, as many of these reports do, that it's a difficult sector to abate. It has particular challenges, and hopefully we'll have a chance to chat about that today. Policy action is important. Almost all of those reports, doesn't matter where you go, policy action is a key component in advancing CCUS, and I think we'll have a conversation a bit about that today, and we have experts on the panel for that. And then identified that amongst the portfolio of options for net zero transition in these industry sectors, that CCUS is a critical part of that. So maybe just to cover off a couple technical elements of it. If you look at the climate goals, 25% of CO2 emissions from energy in industrial processes and 40% of global energy demand are represented by industry, the pie chart on the right-hand side. The second bullet point, the issues around cement, steel, chemicals, really a growing and increasingly urbanized global population is going to be very important, and is going to remain on a significant demand in the future. And the efficiency side of the options is really important for future production. And you notice on the pie chart on the right-hand side, I added a kind of an added to it. It's not really a part of the IEA report, but it's a part of the conversation today. And it's really about the enabling of the hydrogen economy for with CCUS. And so that now includes components of the transport sector or decarbonization of the transport sector. So now, dealing with all of those is a large demand on what CCUS represent. The abatement challenges really has to do a lot with the process emissions. So it's not directly something that can be handled with fuel switching, energy efficiencies and stuff. The sort of darker teal color, if you look at that, that's 2/3 of the emissions in something like cement, a little under 50% for something like aluminum. Significant challenges on the process emission side of things, where that's why CCUS represents a significant advantage in the industrial sector for something like cements. And we have an expert on the panel today to talk to that. The other one that was identified is policy actions. I think this is one of the places where there are intriguing challenges, because there's an identification across much of those reports, much of the studies around the sort of hubs and clusters concept. And that sort of investment, if you like, in shared transport and storage infrastructure becomes critical for sort of enabling industrial decarbonization. And the other one is, as we go forward, is the issue about the markets recognizing, if you like, a premium, but the sort of commercial reality of lower carbon materials, and the public being willing to pay for those lower carbon materials as a part of supporting industrial decarbonization efforts. And now, if you turn our attention just to CCUS, just before we get started in the conversation, you can see that the orange component in the triangle diagram. This is from the 2019 IEA report. CCUS is a significant component amongst those portfolio of options in trying to decarbonize industry. So, cement 17%, iron and steel 15%, chemicals 38%. Different capture challenges across each of those sectors. Some have more dilute CO2 concentration streams. Some have very high CO2 concentration streams, and so some significant challenges. But CCUS sits as a really important component of those portfolio of options. Some of the other things to recognize is that there are large volumes of CO2. These are not, in many cases, are still larger industrial applications are in the megatons per year, and so these are large volumes of CO2 that need to be sort of dealt with, if you like, from the CCUS side, from industrial decarbonization, and investments in the front end for some of these things like storage hubs, transportation systems are multi-years in the making, and so requires some thought. And a part of the conversation today, I guess, which led to a part of the panel conversation a little bit, is this, is the concept around the importance of the hub and storage, hub and cluster kind of approach, where there's collection hubs and it moves it off to storage hubs. Is that because the conversations over the last 2-3 years has been quite exciting, demonstrates just the momentum that is happening in the marriage of all of these technologies, from CCUS through to sort of cost structure for capture and other things. But there's a list on the left-hand side that shows, especially in the Canadian context, things like the Alberta Carbon Trunk Line, which became operational in 2020, June of 2020. Had an investment construction timeline that was quite long, but now that it's in place, is really enabling a lot of work. I think people know about the Northern Lights. There's the UK sort of series of industrial partnerships, Teesside, Humber, March 2021. Air Products recently here in Alberta, in the first part of June, announced a net zero hydrogen energy complex that CO2 from that will be utilized in the Alberta Carbon Trunk Line. Not that long ago, 5 days ago, Pembina Pipeline and TC Energy, something called the Alberta Carbon Grid. The Netherlands, for instance, in terms of a hub and cluster approach, Porthos and Athos. These are significant efforts that are going to be enabling this industrial decarbonization pathway. And so, the question becomes, and now the issue between CCUS industrial decarbonization, the last 2 decades, a lot of time has been spent. The smaller image you see in the bottom right-hand corner is a listing of these sort of 20, I think there were 20 projects that the Global Institute has identified. And the majority of those are all in natural gas processing, moves the CO2 off for enhanced oil recovery, and so on. And so much of the learnings in CCUS have happened in that context. Now, there are a few others, but the majority. And so the question is CCUS that we've looked at over all the full value chain, all the way through to the storage, permanence, safety and security of storage, and so on, in the sort of power generation sector, the green component of the pie chart. If it looks like that, does CCUS in industry only involves small changes. So if I go through the route of industrial decarbonization, am I only having to tweak small things? Am I just moving the paper clips, and there's a few minor changes that represent how CCUS is handled in both sides and these learnings we've had over the last 20 years? Or do I now have a situation where CCUS in industrial decarbonization pathways is actually quite different? Does it represent some other significant challenges that we have to deal with? So as a part of those potential differences and a part of leading into the conversation today, one of the interesting things is that most industrial capture entities in the hub and cluster approach will be separate from those entities. So you have to, in the past, they've been sort of these larger, if you think in Alberta, things like Shell's Quest project, those are all internally within Shell. The capture, transport, and the storage components are all within one entity and handled within one entity, but here they're separate. Issues with credits. They reside with the storage operator only, or how to, only market-driven arrangements handle the issues with credits for the stored CO2. Liability, issues of permanence of storage. So does some liability on the storage side come back towards the industrial decarbonization entity, or how is that handled? What implications does that have on MMV? Environment, social governance issues. The way to think about this is, would it matter where the transport and storage operator takes the CO2? So, there are many reports lately around the challenges to ongoing fossil fuel development, legal cases in the Netherlands and so on. And so in certain cases, if your ESG requirements are such that, the CO2 shouldn't go to EOR, and you have a sort of a corporate governance structure that says that you don't want to do that, but you're just as an industrial decarbonization entity putting CO2 into a pipeline, does it matter where the CO2 goes at that point? Issues with CO2 purity, the capture side for industrial decarbonization, some pretty complex decisions, scalability. And definitely I left the last one, and it's probably maybe one of the more important ones at the moment, is the issue around policy. Does industrial decarbonization efforts require something that's a little different than the power sector? So anyway, those are some high-end comments around this issue of industrial decarbonization and CCUS. And so maybe if I can, I want to take this opportunity to introduce the panelists. Firstly, on the Nestor Quintero Mora is a chemistry and materials expert at CEMEX with a special focus on product technology and innovation. Nestor joined CEMEX in Mexico in 1998, leading the quality assurance group for many of the plants in Mexico. And at that point, CEMEX obtained official certification for all its cements projects. And in 2011, he sort of transitioned a little bit into the CEMEX research group in Europe. It's a great understanding of the European context for some of these challenges, and started to look at quality assurance and technology development, and led some development of patent applications and awarding. So really impressive on that front. Operated or sort of participated in a number of optimization initiatives in the cement operations. So that whole challenge around the portfolio of options, including CCUS, he understands extremely well, and has operated in multiple settings in Mexico, Philippines, Panama, Spain, UK, and so on. And so at the moment, he joins us on the panel from CEMEX as the head of the Global Quality and Chemistry Group at CEMEX, and really sort of trying to lead their initiatives in knowledge transfer and innovation across the full CEMEX family. So welcome, Nestor. Second is Dr. Catherine Romanok. An extensive career in the CCUS field. She's a geochemist and works very, very closely with environmental monitoring programs across much of the programs, CCS projects in the United States, regional partnership projects, was a key research scientist in studying a response. There's some really detailed understanding of stakeholder engagement around some perceived leakage issues, and understands what that means relative to the CCUS industry, and how that might lead into decarbonization, industrial decarbonization. Worked internationally, Canada, Australia, and Japan. Really involved in the UN framework, working very closely with all of the sort of regulatory developments across, globally, in fact, and so very knowledgeable in the full range of challenges around CCUS. So welcome, Catherine. And Drew Leyburn is Assistant Deputy Minister for the Energy Technology Sector at NRCan. So prior to his current position, Mr. Leyburn served as a Director General in various roles at NRCan, worked at the Privy Council Office, and was an associate with McKinsey and Company. And Drew holds his degrees from Oxford University and Bishop's University. And at this particular point, Drew has the sort of the honor of leading the development of Canada's CCUS strategy. You speak to that today, I think, and really at the forefront of what's happening in the Canadian space around policy to support CCUS in Canada. You know, the NRCan itself and its energy technology sector in particular has been really closely associated with clean energy technologies, really heavily involved in the capture space, and sort of working in, well, I suppose all aspects of CCUS, capture, utilization, and storage. And so Drew's responsibility looks after multiple labs, NRCan labs across Canada, ranging from Quebec to Ottawa, and even through into NRCan's CanMet facility here in Alberta. So you know, Drew's experience in this whole area of the policy side for CCUS is substantial, and really looking forward to his comments. So with those, Drew, welcome. Sorry, and so perhaps with those introductions to the panelists, thank you again for joining us today. And so some opening comments, and I think we had decided that. Catherine, I think you were going first, right? I think.
Yes, I think.
Yeah, that's okay. Sorry. Yeah. So if you want, I'll stop sharing, and you can share, and I'll invite you for some opening comments.
Thank you so much, Rick. Let's get this. Thank you, Rick. Thank you so much for that introduction, and thanks so much for the organizers for inviting me today. So as Rick said, I've been in environmental monitoring for about 15 years. So I've been developing and researching and implementing monitoring programs for CCS sites. So this is the perspective that I bring. And let's see if I can get, yeah. So I just want to kind of, you know, orient us in the CO2 storage space. So what I want you to know is that all global regulations and all these drivers for CCUS, they require demonstration of secure storage. And the way this is done at storage sites is through monitoring. And so we monitor in the reservoir, in the deep reservoir, for performance monitoring to ensure that the plume is actually behaving the way that we predicted. And then we also monitor in the environment. So this includes the underground sources of drinking water, the soils, and the biosphere. And this is a really important place to be monitoring because it is the interface between the project and the public, right? So this is where the public lives. It's what they care about. It's where they can understand CO2 storage. And so when we are monitoring in the near surface, we're actually monitoring the very resources that we want to protect. So it's really important in all of these areas to be monitoring for different reasons, but also remember that whether you're onshore or offshore, the ground surface is actually the definition of where leakage occurs, because it is the interface between the storage and the atmosphere. So once your CO2 leaks into the atmosphere, then for these drivers, you're going to need to surrender your credits. Likewise, if you can demonstrate that there's no leakage, then you enable your credits. So the really important point here is that no matter what driver, no matter what financial mechanism is driving CCUS, it's going to require this monitoring. And that's a good thing, because we have these monitoring guidelines are set. They began with the IPCC guidelines in 2006. And after that, every subsequent international regulation has been built upon these guidelines. So the good news here is that we don't need to reinvent this wheel. It's proven. And one of the reasons why these storage monitoring regulations are so successful is because they're non-prescriptive. The people early on that were developing these understood that each geological storage formation is going to be different. And so they don't prescribe certain methods or technologies for monitoring the storage site. They only require certain monitoring elements. And these monitoring elements include, as I said, storage performance in the deep reservoir. Then you need to also be looking around in the near surface to find any anomalies that could signal that you have a leak. But then you have to attribute those anomalies, and you have to understand whether they actually are from the storage project or if they're from something else. And then, of course, if you do ever get leakage, in the rare occasion that you would get leakage, you would need to account for those emissions, and you would need to then surrender your credits. So because these are non-prescriptive, the project developer and the regulator, they sit down and they agree on the specific approaches for each site. So the point I want to make here is that storage monitoring regulations are fundamental to the drivers, to the economic drivers that will be enabling CCS. They're consistent. As you notice on the right, you'll see these are international regulations. They are consistent among all of these regulations. They've been successful. They are actually enabling projects to move forward. And so they are actually enabling the drivers for CCUS. So there, as Rick pointed out, there actually are some mechanisms driving CCUS in the United States at this time. And the two main ones are a tax credit and a cap and trade. So the tax credit, and I will tell you from a monitoring perspective, these are working. There are so many projects being developed in the US right now. Our phones are ringing off the hook with project developers that want help to develop their monitoring plans. But just briefly, I want to say that, so for the tax credit, so the benefits are up there. For the tax credit, it's variable, but basically up to $50 per ton of CO2 stored. For the California low carbon fuel standard, this is a cap and trade. So any life cycle emissions from fuel productions for fuels that are sold into California will have to be below a carbon intensity threshold. If your fuel is above that, you will need to surrender credits, and if it's below that, then you can actually be trading those credits on the open market. But what's really interesting to our conversation here is that for the tax credit, CO2 from any source is allowable. But as you would expect for a fuel standard, really it's only the CO2 from fuel production. So this goes straight into our conversation about fuel versus other industries. Another really interesting thing that could be its own webinar in and of itself is that both of these mechanisms allow direct air capture. So this is significant because a direct air capture unit can actually be put anywhere. It's not tied to the actual industrial source, and it can be moved. So this really, I believe, also could potentially be a game changer. Both of these mechanisms allow storage in either saline or EOR storage formations. But the tax credit obviously is basically only for storage in the USA, where the cap and trade can be significant and can be done anywhere in the world. Both of these mechanisms allow hubs, so they allow someone else to do the storage. And in fact, the credits are given to the owners of the capture facility, but that can be shared among the partners. And then the monitoring requirements, very interestingly, for the 45Q, you have a choice. You can either use the US federal rules or you can use the ISO international standard. And then for the low carbon fuel standard, it's a bespoke protocol that was actually derived by the California Air Resources Board. And then just one last observation that I had is that in a tax credit, the economics are certain. You know upfront how much you can make from how much you store. But for cap and trade, the economics are market-based, so they're going to be moving up and down. I think that, and I'm gonna stop here, but of very great interest to my main point that I want to tell you is that the credits and the drivers can apply to any source that it wants to, right? So if we're talking about CO2 from fossil fuels or CO2 from industry, this is something that can be defined by the mechanism. And then I also want to talk about the monitoring requirements, because I think it's very important that they be standardized. So what I mean by that is that monitoring to demonstrate secure storage is the foundation for these financial drivers. And storage monitoring regulations have been successful. They're robust, they're flexible, and they're internationally consistent. We don't need to reinvent them, and they should not be omitted, okay? Because if we're looking at international cooperation and collaboration on reducing emissions, we need even playing fields across the board. So, and because I'm actually aware that the draft standard for the Canadian Clean Fuel Standard is considering actually omitting any of these monitoring requirements. And so I think it's really important that we think very hard about that when looking at international emissions reductions. And then I just want to stay at the end. So from the storage perspective, the storage formation is an equal opportunity reservoir. It'll accept CO2 from any source. So those are my reflections. Thank you.
And I have to unmute myself. Thanks, Catherine. That was fantastic. It's a great insight, and I think leads into a bit of the conversation. So I guess Nestor, if you want to bring up your slides and your opening comments. Fantastic. Thank you.
Yeah. Thank you, Rick.
Perfect.
Okay, it's on?
Yep.
Yeah. Okay. Thank you very much. And thank you for the invitation. Good morning to everyone. Hopefully you're on this side of the Atlantic, so we're in the same hour. And I want to talk a little bit about climate action for CEMEX. What is that? And it's a complement of what Catherine has mentioned already. For the CO2 as CEMEX, we have defined a very clear CO2 reduction roadmap. Where we're standing right now, we have achieved already 22% reductions towards the industry standard comparison, which is 1990. But we're not stopping there. And the idea is to reach at least 35% by 2030. And we have several initiatives open to reach that CO2 reduction, but we have a very clear roadmap in that regard as a company. Our agenda comprehends not only as a part of the production chain, but it goes from the raw material extraction, the clinker and the cement production, aggregates and concrete, all the way to the construction part of the buildings and the infrastructure. And just to mention as well, in the clinker part, we do have open initiatives such as the use of alternative fuels, the use of hydrogen already as an enhancer of combustion, and on this stage 1, we want to call it that way. The use of decarbonated raw materials as well into our operations in order to diminish the impact of CO2. And as well, technologies to produce clinker, which is the main raw material for cement at lower temperature, or a technology to decrease the CO2 emissions of that very same cement clinker. And as well, on the capturing part and the usage and the storage, we are working on understanding and adopting what is the capturing of CO2 in our processes, the storage part as well that Catherine was mentioning. That is at some point maybe something we need to more deeply understand in order to see how we can take advantage of that. As well, we are overseeing how to produce fuels from the CO2 itself, so that we can recirculate our CO2 in the form of fuels for our processes. Mineralize process as well to capture the CO2 from the flue gas. And as well, other CO2 uses. We have been investigating about what other products or materials we can produce out of the CO2. And as well, we're working right now on a project for using solar calcination. As crazy as that would sound, but that is a possibility at some point. And our ambition as a company is to deliver a net zero CO2 concrete globally by 2050, which by no means is something small. It's a big challenge that we have ahead, but we know that we can achieve that ambition by 2050. Speaking specifically, because we think avoidance is one of the key topics for CO2 mitigation as well. And we have already a large amount of investment on alternative fuels substitution, over $300 million US. But for that, we need to have the technology to substitute fossil fuels in our plants. So it's something that has to be adapted. And as well, on the supply of the materials, the alternative fuel is not there standing for us to take. At some point, we have to process it and to produce it out of some of the feedstock that we have. But that as well is a challenge. It's a challenge for us, but we know we can do it, and we're working towards that part. Just to mention our benchmark, this is our planning in Helm in Poland. We can see how we have reached already a 93% fossil fuel substitution by alternative fuels. It has not been straightforward. It has not been easy. It has not been overnight as well. As you can see there, it has taken 20 years to reach that percentage of substitution. Some up and downs in the way, but it is possible. It is possible, and what we want to and what we're doing is we extract the know-how out of our operations in other latitudes to bring into the Americas, into Asia, into Europe, into the other business units where we operate, in order to foster this CO2 avoidance and CO2 mitigation. I don't know if you have heard about this, but this is as well a very exciting project, LEILAC, which is being held together with a consortia with European funds. But this is something that we are aiming to have as a breakthrough technology, to have a decarbonization and indirect decarbonization of the limestone, so that we can capture that CO2 and use it in other processes, as we mentioned. but it will certainly impact the way we operate and the way we produce cement as we speak. But this is something we are developing, and that we think that this will be a key driver for the future operations in our cement plants. And as well, we are not only looking at some small topics, but as well we are working with the mines, with some partners for the capturing part. Not only mines as well, we're working to develop a membrane system together with other companies, as looking to mineralize or to capture CO2 via the recycled aggregates using nanotechnology as well, or even, as we mentioned, use the sun to decarbonize cement operations. So this is just a glimpse of some of the topics and initiatives and the projects that we're currently ongoing in the company, but that they do show the commitment that we have on the decarbonization of the industry. And of course, or just recently launched brand Vertua, which aims to deliver a net zero concrete. And as we mentioned, our ambition is to deliver a net zero concrete by 2050, but we want to start today. And if we can, we are already making efforts, and we're already delivering some of this Vertua concrete and Vertua cement around different latitudes, soon to be introduced in the US. I think in California, we already launched Vertua, and the idea is to launch it globally in all the operations where we have cement plants and ready-mix plants as well. So this is just a brief overview of the initiatives that we have and the pathway that we're walking already towards a future in action, because we are committed to a net zero CO2 concrete and industry. Thank you very much.
Perfect. Thank you. Thanks, Nestor. That's, clearly outlines the complexities on the capture side for that. So thank you. So next is Drew for some comments from the policy side. So the floor is all yours, Drew.
Great. Thanks very much, Rick. And thanks very much to our host for hosting this conversation. It's always a pleasure to talk about the role of CCUS, and I think particularly as it pertains to industrial decarbonization, it's a really timely subject. As Rick alluded to, NRCan labs, our energy RD&D labs, have been working on issues related to CCUS since probably going back to the 80s, before we were even really talking about it as carbon capture. But what we've seen over the last 5 years, or if we compare to where we are even 5 years ago, there's a much greater recognition that CCUS is more than a technology solution. It's becoming an industry in its own right, with the possibility of new entrants across multiple parts of the value chain. And I think that's a really exciting time for CCUS as an industry. And the IEA, Rick, you alluded to in your earlier slides, the International Energy Agency, they've made it very clear that the face of CCUS might look very differently in 2050 than it does today. More players, more diversity, and many more projects, logarithmic growth in a lot of cases. But that's not to say that we should ignore the great CCUS work that's already happened in Canada. And on the first slide, which I think we'll just pull up here, it talks about some of these things, a sense of some of that great work that's happening already. And Rick's alluded to projects like Quest, Boundary Dam, Weyburn, Midale. These are all projects that show the world how fossil fuels can be produced and consumed with fewer emissions. And through grit and determination, they've shown the potential of CCUS, and really crucially shown how to make our next projects even more cost effective. And so, just going to that question about, fossil fuel related CCUS versus other industrial emissions, there's some common challenges that run across all applications of CCUS, and a lot of them have to do with bringing down the cost of capture, which is a crucial part of that value chain proposition. If we want to see a lot more CCUS. Since those original projects that we supported along with Alberta and others, we've at the federal level brought in a number of other CCUS enabling measures, things like national carbon pricing, which is rising gradually to $170 a ton by 2030, a proposed clean fuel regulation, which is expected to create CCUS related compliance credits, and on a more macro level, national legislation enshrining a net zero emissions target for 2050 and a 40 to 45% GHG reduction across the economy by 2030. And in a jurisdiction like Alberta, all these federal measures would be in addition to provincial CCUS measures like the tier credits, the offset system, and a new proposed pore space regime. We know that we'll need to take advantage of that know-how, the history, the expertise, the geology that we have in Canada to mitigate emissions in some of the other hard to decarbonize industries like cement, iron, steel, fertilizers, et cetera. We also know that it'll be key to enabling other low carbon pathways such as hydrogen. And so that's why we've supported projects like the Alberta Carbon Trunk Line, which Rick, you alluded to earlier, which have allowed an expansion of that CCUS family to bring in new entrants who might not otherwise be able to play. One of the benefits of taking the CCUS hub approach is that it makes it easier for people to join in without having to invest in duplicative transmission or storage infrastructure. And so we really do welcome those new entrants. We love the fact that we're broadening that CCUS family. It's why we've supported companies like in the carbon use space like Carbon Cure and Carbocrete. It's why we're supporting companies in the DAC space like Carbon Engineering. And maybe just moving to the next slide, speaking of support, a few months ago, the Canadian government announced it would be developing a comprehensive CCUS strategy for Canada, which we're expecting to land by this fall. And while it's still very much in a formative stage, we know that industrial decarbonization is one of the 6 pathways where CCUS will need to play. And that CCUS strategy will be backed by a number of federal measures, like a proposed investment tax credit, which is to come into effect next year for capital invested in CCUS projects. That's currently being consulted by my colleagues in the Department of Finance. $320 million, which will be directed towards CCUS related RD&D, and access to billions in funding for industrial decarbonization projects through vehicles like the SIF Net Zero Accelerator and the Canadian Infrastructure Bank. A lot of these investments, by their nature, need to be foundational. They need to work for not just one segment of the CCUS value chain, but all parts, new entrants, incumbents, some of the more traditional uses of CCUS. Because very similar to what we did with the hydrogen strategy at the federal level over the last year, we wanted to be colorblind with that, not get too focused on blue versus green, but to allow the hydrogen industry to expand in an organic way. I think the same is true for CCUS. We want the measures, we want the enabling foundational investments that we make to be good for all parts of that CCUS value chain, including in the some of the process-related emissions or the lower concentration CO2 projects that we know are going to need to be part of CCUS by 2050, certainly. So there's lots to be excited about right now when it comes to CCUS in Canada, and I'm glad to be sharing the stage with my colleagues from Mexico and the US, as I know there's actually a pretty great North American story to be told when it comes to CCUS. So I think I'll stop it there to allow for the conversation to continue.
Fantastic, thank you, Drew. Yeah, and I'm glad you added some of the notes on a new strategy road mapping exercise that you guys are leading. That was fantastic. So maybe Drew and Nestor and Catherine, if you want to well, you can't unmute your video. I guess you unmute your mics. I was going to say unmute your videos. It doesn't quite work that way. So I'm kind of conscious of time. I think all 3 panelists, you guys have provided some fantastic inputs on some of those CCUS challenges. But in trying to pick up maybe a question that links to some of the conversation amongst all three of your opening comments. So maybe each of you, maybe in turn with the order we went in. I'm still intrigued to get your thoughts about how the issue of credits is managed in a industrial decarbonization strategy where the industry proponent is separate from the transport and storage person. Like, is it going to be simple? I guess, and I don't know the answer to that. Maybe it's just a commercial, market-driven negotiation with lawyers in a boardroom, and it's a commercial thing, or is there something else that's going to be at play when you think about storage credits or permanent demonstration of permanence? Because Catherine's point about monitoring, Drew, you're in your case, you didn't use the word agnostic, but so you used sort of a word
colorblind.
Colorblind, that's the word. So you say, okay, well, that's fine, the system. And in your particular case, Nestor, you're trying to move that net zero decarbonization pathway, and some of the value is monetized in those credits. So, what are your thoughts about whether that does or does not represent a challenge for CCUS in an industrial decarbonization pathway, Catherine?
Well, I think it's a good thing because, and Nestor can attest to this, but he's in the cement business. He's not in the storage business. So it makes it a lot easier for him in many ways to be able to, have a place to put his CO2. And it's very much like any other kind of a waste disposal. I mean, I pay, for my trash to be taken away and disposed of. So I don't have to worry about that. So I think it's a good thing in that way. As I said, the current drivers in the United States are allowing the credit to be mostly given to the owner of the capture equipment. But then, of course, there will be partnerships that have to come through this transport, capture, and storage partnerships. And those, I believe those have to just be worked out among the partners.
Okay, great. Nestor, your thoughts on, just to challenge you, I guess, a little bit from even what Catherine said, is that, yeah, you're in the cement business. You're not a storage operator, but when you have those conversations about what the storage permanent side looks like, does that mean that CEMEX now has to hire its own storage experts in order to understand that portion of the business? So how do you see that evolving specifically for somebody like yourselves in a global cement industry?
Yeah. Thank you for the question, Rick. And storage is something that we have to keep very close on the side for the cement business, but we are really trying to go for the avoidance or the mitigation on site, so that we don't generate the trash. I don't want to say trash, but this byproduct, because we know that there are possibilities to use it and to transform it, for example, into fuels or into other useful products. And why not take the chances to go that way first? But we have to be cautious, and we have to take storage walking the same way as for mitigation and avoidance in the process. Because at some point, maybe there won't be a silver bullet for this. We'll have like a combination of different perspectives and technologies in order to reach the net zero cement and concrete.
Okay. Interesting. And Drew, how about yourself? I think
maybe I'll just say really briefly. This is one of the reasons why we want to make sure that whatever policies we put in place, that we're minimizing the barriers to entry for new players, and for opportunities to make money. Every part, Peter Terzaki and many people in Alberta will know Peter. he always says that, every part of the CCUS value chain is going to have to make money. By lowering the barriers to entry, people will find a way. People will find a way to make it easy for their clients. I think about a company like Svante in Canada. They've made it pretty easy for a company to contemplate a CCUS retrofit now. The company doesn't have to become a CCUS expert to be doing CCUS. Conversely, I think there's a lot of incumbent players today, oil and gas companies, for example, who 10 years from now are probably going to have either a CCUS arm or maybe even a spin-off company that is, selling CCUS expertise to other parts of the economy. I think that's going to be really welcome. And as I said, everything that we do, I think we need to make sure that we're finding ways for people to bring their ingenuity and make their clients' lives easier.
Yeah, and I think, and to that point, I think that transition is happening already. You already see people, taking some of that subsurface expertise and wanting to become that
storage provider, right? Pore space.
And even I mentioned this the other day that even in dealing with pore space legislation, I'm not sure how it works in the United States, Catherine, but in Alberta, for instance, the Alberta government has actually just issued this information letter that says that we're going to manage direct pore space for storage operations in a very competitive manner, in a way that we will allow access to the pore space by a storage operator that has to allow multiple entrants into. You can't restrict access to the pore space. You have to have lots of options. So yeah, you can see things moving very, very, very much in that way. One of the things that again, maybe this is just because of the last 2 decades, again, of work where it's been power generation, coal-fired power, boundary dam kind of projects, CO2 EOR kinds of projects. Maybe to your point, Drew, and then maybe to get Catherine and Nestor's things, is that in your case, as you go forward, you don't see any this decrease in the fossil fuel side, this sort of global thing about wanting the energy transitions faster and bringing fossil fuels down, that there's even a reason to support industrial decarbonization more than you would otherwise support power generation? Like, do you see that there's a reason to accelerate support for industrial decarbonization, or it's just pretty much the same?
Yeah, in that sense, the landscape has shifted a lot in the last decade, right? When we and Saskatchewan and others were making our commitments to Boundary Dam, we had a different plan trajectory for coal-fired power, in the mid-2000s than we do now. And so in Canada, you're not likely to see a lot more. Well, you're not going to see any CCUS coal-fired plants in Canada, I don't think, after Boundary Dam. But that's because there are alternatives in Canada. It won't be the case around the world. And I think that's what it's going to come down to is, how does CCUS stack up as a mitigation, as a decarbonization solution compared to other technologies? So in the oil sands, there's a lot of excitement around the possibility of CCUS in the oil sands. There's also solvents and other alternative extraction technologies. There's, I think in some of these industries like cement, CCUS might become the sole technology option. So you're going to see a different interest from those companies than maybe you will get from another industry that has 20 different technology options. So anyways, I think there's no probably easy answer here.
Okay, and maybe Catherine, in the United States, do you see a focus that might shift to industrial decarbonization efforts, or will it stay, much in the sort of power energy type applications?
Now, there's definitely a huge role for industrial decarbonization. And I think you're making a really good point, Rick, which is, there's a public acceptance issue here. And I see it mostly in the UN space, where the people that are most passionate about reducing emissions into the atmosphere actually kind of against CCS, because they think it's an enabler of fossil fuel production. And really, this is not a helpful place to be. And so, yes, making the public aware that there are very hard to abate emissions from industry is very eye-opening. The other thing that's been extremely eye-opening is direct air capture. It's amazing to me when you think about capturing CO2 off an industrial stack that is percentages of CO2, and you look at the atmosphere that has parts per million CO2, but the public loves direct air capture, and because it makes sense to them. There's too much CO2 in the atmosphere, so let's take it out. So the public perception of CCS, I agree with Drew, it's changing, it's shifting, it's good. Decarbonizing industry is really important to that. Direct air capture is also important to that. And so I agree with what you're saying. I think it's really important.
Okay. And maybe since you're, you truly are the industry guy on the panel, Nestor, I'm conscious of time. Maybe we'll give the last words to you and your thoughts about, I guess I think in your particular case, and if you just take the Mexico context, if you think about that pathway, is there a pathway there where you can, I don't know, decarbonization of the cement industry yourselves takes on more importance than something like the fossil fuel CO2 EOR side of things? Do you see that kind of conversation happening? Yeah,
Rick, that is definitely happening in the industry. And for us, really is a very important topic, is a key topic that we are trying to drag our efforts towards this part. We know it's not going to be easy. As we have seen, the storage part it has its implications. The carbon capture technologies are getting mature, some faster than others, and there are many players popping up everywhere and trying to come up with a solution. Not all work the same way, so we have to acknowledge the fact that there are limited options, but we do have as well to explore helping on the development of those options, or working together with these companies, because if not, by themselves, maybe they're going to take double the time. So we need to devote efforts, and I think somebody mentioned CO2 experts. We do have already CO2 experts as well in the company, working on these topics and trying to foster this decarbonization for the cement operations.
Perfect. Okay. Well, I'm conscious of the time. So listen, maybe to close off the session, Catherine, Nestor, and Drew, thank you guys very, very much for the opening comments and the conversations. Fantastic. I tend to, in this space, always, especially with things that are moving this fast, is always the way to conclude is to, we're going to get back to flying. So the flying analogy is to return your chair to its upright and locked position and fasten your seatbelt, because it's a fast moving thing, and we might already be flying at altitude. So thank you, Agal, very much again for joining us on these North American Energy Dialogue series. And I think at this point I might turn it over, to Anne to close off the webinar. Thanks.
Great, thank you. Good closing comments there, Rick. Rick, Catherine, Nestor, Drew, thank you so much for this enriching discussion on CCUS and its role in industry decarbonization, and also a glimpse at the opportunities and the challenges that lie ahead. I thank everyone who joined us today for the 4th webinar in this North American Energy Dialogue. The webinar has been recorded and it will be posted on the Energy System Signature Area website, on the U of A website, in the upcoming few days. A few other thank yous. Thank you for the hard work from our partners in this webinar series. Tech de Monterrey, Dr. Louis Serra of the Energy Initiative, University of Texas at Austin, Dr. John Butler at the Kay Bailey Hutchison Center for Energy, Law, and Business, and Jorge Pinon at the Jackson School of Geosciences. And thank you also to Christian Gonzalez Pais from the University of Alberta International for his extensive work in developing this webinar and this series. And thank you, Alexis, from the University of Alberta International as well for the technical assistance. It's always great to end a webinar with so many questions and so much interest from people. So thanks everyone again, and I wish you all a pleasant rest of your day.
Indeed. Take care. Thanks again. Bye, everybody.